SC28C94 QUART Universal Asynchronous Receiver Transmitter by NXP. Welcome to the training module on NXP's SC28C94 QUART Universal Asynchronous Receiver Transmitter. Our outline consists of an overview of the 28C94, block diagrams, internal operations, and application information. A universal asynchronous receiver and transmitter is used for communication with serial input and serial output devices. Serial transmission reduces the cost and complexity of the wirings at the expense of speed, and for many applications this is a desired trade-off. Universal asynchronous receiver and transmitter provides a serial asynchronous receive data synchronization, parallel to serial, and serial to parallel data conversions for both the transmitter and receiver sections. These functions are necessary for converting the serial data stream into parallel data that is required with digital systems. To a host system, the universal asynchronous receiver and transmitter appears as an 8-bit input and output port that it can read from and write to. Whenever the host has data to be sent, it just sends the data to the universal asynchronous receiver and transmitter in byte format. Whenever the universal asynchronous receiver and transmitter receives data from another serial device, it will buffer the data into first in, first out. The 28C94 QUART Universal Asynchronous Receiver Transmitter combines 4 enhanced Philips semiconductor industry standards that can vastly minimize host processor overhead. The operating speed of each receiver and transmitter can be selected independently at one of 18 fixed baud rates. A 16x clock derived from a programmable counter or timer, or an external 1x or 16x clock. The baud rate generator and counter or timer can operate directly from a crystal or from external clock inputs. The ability to independently program the operating speed of the receiver and transmitter make the QUART Universal Asynchronous Receiver Transmitter particularly attractive for dual-speed channel applications such as cluster terminal systems. Each receiver is buffered with 8 characters, first in, first out memories, and 1 shift register to minimize the potential for receiver overrun and to reduce interrupt overhead in interrupt-driven systems. In addition, a handshaking capability is provided to disable a remote universal asynchronous receiver transmitter when the receiver buffer is full. The 28C94 also provides a power down mode in which the oscillator is stopped and the register contents are stored. This results in reduced power consumption on the order of several magnitudes. The QUART Universal Asynchronous Receiver Transmitter is fully TTL compatible and operates from a single 5-volt power supply. As shown in the block diagram, the QUART Universal Asynchronous Receiver Transmitter consists of data bus buffer, interrupt control, operation control, timing, and 4 receiver and transmitter channels. The 4 channels are divided into 2 different blocks, each block independent of each other. Each block contains 2 sets of receiver and transmitters. In the following slides, the different functional blocks will be introduced. The operation control logic receives operation commands from the CPU and generates appropriate signals to internal sections to control device operation. It contains address decoding and read-write circuits to permit communications with the microprocessor via the data bus buffer. Mode registers 0, 1, and 2 are accessed via an address counter. The mode registers control the basic configurations of the universal asynchronous receiver transmitter channels. The timing block consists of a crystal oscillator a baud rate generator, power up-down logic, and a divided by 2 selector. The crystal oscillator operates directly from a 3.6864 MHz crystal connected across the X1 or CLK and X2 inputs with a minimum of external components. If an external clock of the appropriate frequency is available, it may be connected to X1 or CLK. If an external clock is used instead of a crystal, X1 must be driven and X2 left floating. The clock serves as the basic timing reference for the baud rate generator, the counter or timer, and other internal circuits. The baud rate generator operates from the oscillator or external clock input and is capable of generating 18 commonly used data communication baud rates, ranging from 50 to 38.4K baud. 18 sources which may cause an interrupt are listed on this page. The interrupt control for the QUART Universal Asynchronous Receiver Transmitter has been designed to provide very low interrupt service overhead for the controlling processor while maintaining a high degree of flexibility in setting the importance of interrupts generated in different functional blocks of the device. The interrupt logic at each source produces a numeric code that identifies its interrupt priority condition currently pending. The code contains the identity of the source, channel number, and severity level. This code is compared to an interrupt threshold. When the interrupting source generates a code that is numerically greater than the interrupt threshold, the IRQN is asserted. There are 2 blocks each containing 2 sets of receiver transmitters. One block contains channels A and B, and the other contains channels C and D. The QUART Universal Asynchronous Receiver Transmitter has 4 full duplex asynchronous receiver transmitters. The transmitter accepts parallel data from the CPU and converts it to serial bit stream on the TXD output pin. After the transmission, if there is no new data in the transmit first in first out, the TXD output remains high. The receiver accepts serial data on the RxD pin, converts the serial input to parallel format, checks for the start bit, stop bit, parity bit, or break condition, and presents the assembled character to the CPU via the receiver first in first out. There are 16 multi-use pins, 4 for each universal asynchronous receiver transmitter. They can be individually programmed to be inputs or outputs. The counter timer is a 16-bit programmable divider that operates in one of the 3 modes: counter, timer, or timeout. In the timer mode, it generates a square wave. In the counter mode, it generates a time delay. In the timeout mode, it monitors the time between the received characters. In addition to normal transmitter and receiver operation, the QUART Universal Asynchronous Receiver Transmitter incorporates a special mode which provides automatic wake-up of a receiver through address frame recognition for multiprocessor or multi-station communications. In this mode of operation, a master station transmits an address character to the several slave stations on the line. When the receiver sees a 1 in the parity position, it considers it an address bit and it loads that character to the RX first in first out and set the RX RDY bit in the status register. The local processor at the slave station will read the address character just received. The local processor will test for an address match for this station, and if match occurs, it will enable the local receiver and receive the following data characters. The QUART Universal Asynchronous Receiver Transmitter has been designed to interface in either the synchronous interrupt environment or the asynchronous interrupt environment. The interface pins are all active low. The pins used for normal reading and writing to the QUART Universal Asynchronous Receiver Transmitter are chip enable, read enable, and write enable. The pins used in the interrupt service are interrupt request or interrupt acknowledge. The pin used for data transfer is data acknowledge. Interrupt request and data acknowledge are open drain outputs. In the asynchronous mode, all of the interface pins are usually used. The synchronous mode usually will not use the interrupt acknowledge and data acknowledge pin. With the rapid development of global positioning systems, GPS gets wider application in many fields. GPS mainly includes antenna interface, DSP, microprocessor, memory, data interface, and a power interface. The data interface of a current GPS can be Universal Asynchronous Receiver Transmitter, USB, or Control Area Network. The simpler transport protocol of the Universal Asynchronous Receiver Transmitter results in much less software overhead and more cost-effective hardware solution. The block diagram shows using the SC28C94 4-channel Universal Asynchronous Receiver Transmitter to achieve a GPS navigation system. Bluetooth wireless technology is becoming a popular standard in the communication arena. It is convenient, easy to use, and has the bandwidth to meet most of today's demands for mobile and personal communications. Devices equipped with Bluetooth technology support wireless point-to-point connections, as well as wireless access to LAN, mobile phone, network, Ethernet, and home networking. Unfortunately, the most popular host controller interface today is either Universal Asynchronous Receiver Transmitter or a USB link. However, Bluetooth semiconductor companies offer many versatile host interfaces to allow this integration to be glueless and requires no external component. But a Universal Asynchronous Receiver Transmitter provides a simple, proven, and fast interface. The block diagram shows a detailed interface of a Universal Asynchronous Receiver Transmitter to host controller and Bluetooth module.